This is why she wasn't losing weight.
I worked out every day for a year and just lost.
Welcome back today. Let's do some more studying, a little bit related to day work. It'll be about FANUC, dependence, and robots and PLC in general. Yeah, let's go. But why does FANUC not teach how to use your own product for free? Makes sense.
FANUC educational package. Educational package. The FANUC Educational Package. Robotics training for schools and universities. Hands-on learning. For the future of automation. The package contains everything schools and universities need to teach students to program and operate industrial robots.
coverc.com/Chinese 了解詳情。
Do you love boating? Well, Freedom Boat Club makes boating easier than ever.
And teach points to robot arm and mechanism. And 2. This button will enable or status, display real and application. Y positive. Y neutral. If I'm going to move X positive, so I'm going to move X negative, I'm going to move Y, I'm going to move Y positive, I'm going to move Y negative, I'm going to move Z negative, I'm going to move Z positive, I'm going to move J4, joint number 4 or axis number 4, axis positive, axis 5, joint 5 negative, joint 5 positive, joint 6 negative, joint 6 negative positive,
Hi guys, and welcome to the next video. Today we're going to talk a little bit about creating a program. I'm going to split that video into two parts because there is a little bit of stuff that I want to cover. So today we're going to focus mainly on how to create a program, what are the program properties, and creating a point and a few points, and what the program should have at the start. And then in the next part I'm going to talk a little bit about the options that you have in the program, what you can add to it, and so on and so on. In order to do the program, you need to see the other videos though, the one how to make a user frame and tool frame, how to do the mastering, and how to create a payload, because we need that information in order to create a program. And you need to know how to use it so you can actually create the program, jog the robot to the correct positions, and so on and so on. So guys, again, go there, take it out, and we can jump right into creating the program. So without further ado, let's get to the exercises, and I'll explain everything to you back there. Oh, please don't forget to subscribe, hit the like button, and right now we are ready to go. Okay guys, so welcome to the exercises. So we're going to create your first program today, and I'm going to tell you a little bit about what type of program we can create. But we're going to focus just on the main program for now. The next one I will talk a little bit more in the next video. Okay, so let's get to it. First of all, you want to hit select, and that's where all of your programs are. Now, as you can see, there is a function menu in here. When you hit next, there is
Looks
more
different from what I have.
So we'll talk about that now, because you need to know what's going on before you create the program. So the first one is a type menu, and in here you can choose the program type that you wanna look at. So as you can see, we have all programs. You can select collections. You can select teach-pendant programs, you can select chiral programs, macros, and condition handlers. And we're going to talk about all of those in the next videos. Today, we're going to focus on the teach-pendant programs, and that's your main program. In those type of programs, you're going to put all of your movements, all of your logic, you're going to call sub-programs, and so on. So we'll start with that one, and that's the most common used program. All right. I said we're going to talk a little bit more about the menus. So the delete one, you can delete the programs with that. So whenever you hit delete, just in case you make a mistake, you still can say no or yes. When you hit yes, you will delete the program that was highlighted by the bar. The next one is monitor. We cannot use it right now because we are not running any program that's used when you are running a program. Attributes. So attributes are the things that you can see in here, and you can change it. So you can change it the comment, so it will show the program comment. You can select protection type. Either it's write protected, that means you cannot change anything in the file unless you turn off the protection. Last modified, that's very nice, that's very important. So that's showing when the file was last opened in editor. So you can take a look if someone changed something and if he did, when that happens. Really nice option, guys. Remember that one. Next one is size, so you can take a look at the size of the file. Copy source, so if the program was copied from another program, then you can take a look where it was copied from. So for example, looks like the maintenance position was copied from a home program. Next one is the name only, so that will show you just the programs. The one I recommend mostly is probably comment, because you have a program name and then you have a comment that you can take a look at and get a little bit more information. Okay, in the next menu, there are a few pretty nice buttons that you want to know. First of them is copy. So that's what I said. When you copy the maintenance program to, let's say, maintenance 1, and we hit enter. Do you want a copy? Yeah, we do. And right now, when we will change the attributes to copy source, as you can see, our maintenance program is saying that it was copied from the maintenance. Alright, the next one is detail. So that's showing the program details, and we'll talk about those in a moment when we go to a program creation. Because you gotta, when you create a program, you gotta choose all of those. Okie dokie. Next one is load. So we can load a teach panel program. We don't have anything plugged into the USB right now. I will show you in a moment how that works. Next one is save as. So that will allow us to save our program to a directory that we can choose. So let's say we have a directory in here. Let's create one. If you don't know what I'm doing right now, guys, you gotta watch my backup video. I'm explaining everything over there, how to create a backup, folders, and so on. Okay, so when you click save as, we're going to save the file to the directory that I selected before. So when I do save, just that one program is copied to that file, to that directory, I'm sorry. So when we go UD1 to load, we open it, and we have the maintenance program saved as a TP file. Awesome. You can do print, which is even more useful. When you do print, remember that you need to pre-select the destination like I did. So I'm going right now to print the maintenance 1 program to the UD1, and we hit enter. It's going to save it as a ls file in the destination. So we go again, file, UD1 load all. See, we have the maintenance 1 saved as a listening file, which can be edited in the notepad. And we have the maintenance file saved as a binary file as a teach pendant program. Okay, awesome. Now let's go back. Oh yeah, we have the load one left. So you can load the teach pendant program. So we can load, but it's saying that already exists, and do you want to override, yes or no? So we can override it, and it's loading the program out of the pre-selected directory. So guys, whatever you select in the file, he will try to load from here whenever you push the load button. I hope that's clear. So let's get to creating our first program. Okie dokie. So we're going to hit the create button. And the first thing you gotta do is you gotta give the program a name. Let's name it first program. First program 1. Okay, I hit enter, and you're inside the program. Now let's go back, because I want to show you a few options. So also when you hit create, and you will give it a name. Oops, sorry, wrong button, guys. One more time. I'm a little bit too used to the keyboards. Okay. Instead of hitting enter right now, you can hit detail, and it's going to take you to the program details that you can edit. When you hit end, you are going back to the program. In case you don't change the program details before you do anything in the program, or actually also after, you can always go to the detail, and in here you can change whatever you want. So let's select our program 2 that I created. Let's go detail. And right now, what can we change in the detail? The first thing we can change is the program name. So if you want to change the program name, you're going to hit enter, and you're going to change the program name to whatever you want. Hit enter, it's changing the program name. Second thing is subtype. So in here, you're going to select what type of program do you want to create. Now there are quite few options. First is none. None means by default a teach pendant program with a TP extension, and in the teach pendant program you can pretty much put and do everything. There are no limits, of course, except for the Carol logic that can be used only in the Carol programs. But besides that, you can put motions in there, so the points, you can put I/O, you can put registers, you can do logic, you can do many things with it. The next one, and that's the one we're going to create today. The next one is a collection. Collection is not really a program. You can think of it as a folder that you're going to put programs in. So it's like just to keep everything more organized in a robot. Personally, I've never used it, but I will talk about it on the next lesson. Next one is a macro. Macros are specific programs. They can have motions as well, but usually they are designed to do not have motions in, because then you're allowed to do much more with them. You can assign the macros to a button, so whenever you push that button, something can happen, like let's say gripping can open or close. You can assign it also to this button. You can assign it to the operators button that are on the robot controller, and other things. Again, we're going to talk about those in the next video. And we have also the condition handlers. So those are the programs that you can create, and they will kind of monitor what's going on with the robot, and they work as interruptions. So in the condition handler, you're going to say if something happens, then run the condition handler, basically. And again, that's for the next video. So we want to select none for now. And right now we go down, and what you can do, you can put your command in here. So we have our first program, which is first program 3, but maybe you want to add some specific comments to it. So you can name it as Future Robotics first program. So everybody knows like what that program is, who created maybe, and what is it for. It's useful, guys, because program name can have only 16 letters, so you can use the command to give it a little bit more details. Group mask. What is a group mask, guys? Group mask basically saying how many motion groups are used in the program. So you can choose between asterisk or 1. If all is asterisk, that means there are no motion groups, so robot will not move in that program, and usually those are used for macros. We want to execute some moves, so we're going to leave it as 1 in here. If you have, for example, a servo gun that's configured as a second group, you want to put 1 in here as well. I cannot do it because I have only 1 motion group installed. Write protect. What is a write protect, guys? Whenever it's off, everybody can make changes. If you change it to on, nobody can make changes to the program. So let me show you. We leave the write protect on. We're going to end. So we have our first program 3. Even if it's a good habit to execute the program backwards, so we can hold shift and hit backward.
The thing that's different about a Verbo vacation home, you always have the whole place to yourself. Just you and your people.
What could you do with a metal 3D printer? Introducing the Metal X, the easiest way for you to go from design to real metal part. Tools and
Today we'll be learning on how to write the number 6 with the FANUC robot. We'll go over the program to refresh on how to create the number 6 and step through that are easily forgotten. We'll step through the program to make sure that all points are correct before running it in a continuous motion. Just explaining some of the points of the program will be the position register, the weight, the IO command, and why you have to have them in the program.
First thing to do in verifying a program is to make sure that you have your teach pennant in the step position. To verify that it's in the world coordinates. What you want to do in the step position is it steps through each individual coordinate so that you can verify each position as it goes along, making sure that everything is free of obstructions. First thing to do is jog it into the first position. Which is our registry position. Our registry position is a position that we define above our beginning that is free of all obstructions, clear of all parts. Next thing to do is to open the grippers, and we program a wait command. A wait command allows enough time for the grippers to open before it approaches the top of the marker. Same thing to do is to close the grippers with another wait command that allows the grippers to close again before retracting the marker from its home position. Now it moves back to its registry position. In the registry position, we've already acquired that it's a position that is free from all obstructions and the marker is not going to hit anything. The next program, the next point in reference is to do a linear motion somewhere above our workplace that is going to assure that the marker is not going to hit anything. At this point, if we were to want to program a spot that was the starting point, we would run the risk of the marker hitting the fixture in which it came out of. So now that we know that we're clear of obstructions, we can now approach our first position. At this point, we're going to do our first motion, which is a linear motion to start the 6. And now to do the circle of the 6, you need to program circular motions. The first point of the motion is for which it starts. As you may have noticed, the grippers that we have for these markers do not hold the markers correctly each time. So we had to make an adjustment to the marker position so that it's going to be able to go back into its home position correctly. So at this point, that's what it's going to do. And then it's going to open the grippers. It's going to give a wait command of a second to allow the time for the grippers to open. It's going to complete the program by returning to the robot's home position that was already programmed. So at this point, we've successfully tested and stepped through the program. The next step is to run it in continuous mode. In continuous mode, by running in continuous mode, you just simply take it out of the step mode.
Alright, now we'll be going into the automatic mode where it'll write the number and return the pen.
Hello, it's Peter. This video is to demonstrate how the FANUC robot communicates to your Rockwell Automation PLC. So there's a whole lot going on in this screen right now. I'm going to start with focusing on the communication settings between the FANUC robot and the Rockwell PLC. So first of all, you have to add the FANUC robot to your PLC's Ethernet. So here's my EN2T PLC card in my rack. It creates this Ethernet card. You create a generic Ethernet module for the PLC. Please go with the IP addressing you have in your documentation. Yeah, this is a little different for my virtual robot to physical PLC. So again, focus on the PLC address that you are given for your capstone project. Then I have some logic here. And this logic I'll come back to later. So we're going to focus on just the digital inputs and outputs. So after you created this module, and you can see here I named this FANUC ENET, so for Ethernet, that creates tags. So here's your FANUC ENET. Here are my inputs, my outputs. And over here, you can see, in this screen, I have the digital outputs on the FANUC robot. This is the monitor screen that you're typically in. If you press this config button, you can see you can config a range of outputs and map them to Ethernet. So rack 89 is Ethernet IP, slot 1, and I'm starting at point 12 for the digital outputs. Because the first 11 points are used for the user operator signals like IMSTP, hold, cycle start, fault reset, and other items that we'll come back to later. This should already be set. You can verify this. These numbers may vary in your system. You just have to figure out, okay, which one of these inputs and outputs, corresponds to my tag in my PLC. The easiest way to test this is digital outputs here on the robot side. They're received by the PLC as inputs. So I go into my ENET. I'm going to go to 0, and you can see I already have all these labeled here of what they are. And you can see, starting with point 11, which is the 12th signal, I can see coming in from the robot. So this is coming from digital output 185 from the robot. I'm going to use this a different one because I have some logic tied to that. I'm going to go to DO186. I'm going to be sure to cursor on the on-off signal. So if I turn this output on in my robot program, you can see it's received here as input data 0 bit 12. So this would be digital output 186 from the robot. So I can turn this back off. I can switch to my inputs on the digital outputs side. I have to scroll down quick to 185. So here again, you see I have inputs on the FANUC robot. It's important to remember that these you cannot easily turn on because they come into the robot. Okay, so anything comes into the robot comes out of the PLC. So here I go to my ENET 0 data, and here's my outputs, and you can see I have these mapped to some user operator interface signals again, and same as the signals coming from the robot. If I send something to the robot, so here's my signal 12 And since this is an output from the PLC, I can turn this on in the PLC. I can simply type a 1 in here. You can do this as long as it's not tied to any logic. Type a 1, and you can see here on the FANUC side, the input is received. DI-186 is received. So this is how you can send something from the PLC to the robot, which in this program you see here, I'm going to run this in just a second. You can see I'm already, there's a wait statement, and it says, wait for the digital input 185 to turn on. Yeah, so I'm waiting for the PLC signal before sequence. The start-stop is a little different than what you will find on your physical robots. I still have these signals here, so be sure to focus on what you will have on your physical robots. I gotta change this back so you can see. I also have to move this down a little bit because I created a HMI up here. I want to be sure you can still see the fault signals here. And so here, this is a push button that resets any faults. So there's a physical push button on your cell. When you press that, you can set that signal to send the reset command. Same as you set the same command that you would press in the physical teach pendant. So when I press this signal is seen, and my fault is reset. Next, we have to make sure that all our systems are ready to go. So, there are a couple of commands that I want to have from the robot that tells me that the robot is ready. That's because I'm sending these 4 signals to the robot. This is something that you do not have to do right now. We'll come back to this later. I just want you to understand where the system ready signal is coming from. I'm also looking at this faults. So there is a fault, which is our safety relay. So I have to reset, and this button up here is indicating to me that, hey, there's a fault present, and you have to reset that fault. Once I reset that fault, I have an internal indicator that says, yep, all systems go, no faults present. So I press this. Okay, that tells me now I'm reset, safety is good, which gives me this run signal, and that also sets for my virtual start. So when I press the start signal down here, you're gonna see the UI6 come on, and once it goes off, you can see that it jumps to 1. This looks for a signal transition from true to false. So it doesn't start running when you turn it on. It starts running from the transition from it was true and it goes false. Okay, so now it received the start signal. The robot is at this wait position right now, but it's because it's waiting, for this DIA-185 to turn on. Which think about a part coming down the conveyor. The part comes down the conveyor, and the sensor sees the part. The robot sees that signal. Okay, so this is the signal the robot would receive, and I have to turn this on. I have an HMI button to turn this on, which sends the output to the robot, which sees it as DI-185. So once it sees that signal, you're gonna see the robot do some quick circles. Really no particular motion. When it's done, it turns on 185, which is this signal down here, which I just have an internal tag to tell me, yep, it is done. Okay, so I'm going to click the part present. Now the robot starts running, and it's going to complete its motion. Once it's completed running, you can see the signal come on. That tells me, okay, the part was loaded. Now I can do the next thing and maybe turn the conveyor back on. So this is a quick overview of the exchange of digital inputs and digital outputs between a FANUC PLC and, a FANUC robot and a Rockwell Automation PLC. It's important you have your processor configured, important you have your Ethernet module configured based on the instructions I gave you, And yeah, there's some additional settings we may have to double check in your robot controller. But for the most part, that should all be set from previous projects. And again, this focus is just on the exchange of inputs and outputs between PLC and robot, yeah, on the digital outputs, digital inputs. All right, that's all I got. Thank you.
Ooh. It's basically internet. The stream